few people on illegal drugs. You know, I used to work inner city kids. They were sniffing glue and stuff. So
has anyone came into like class?
I think it's too early in the morning.
No, like just any classes taught.
Oh yeah.
Really?
Oh wow.
What do you do?
Usually, we'll step out, go across the hall, call security, and say, "Hey, this is what's going on." But that's about it. All right, let's take a look at the homework work. Those of you who are not soon to be juniors and soon to be seniors next year, don't worry. I plan on sticking around here for at least 20 more years, so I hope so. Hope so. All right. I don't want to necessarily do the perpendicular bisector of ABC because I have plans to show you that later today, but I will do any of the other problems on the homework. Let's not go to the proofs yet. Do you want to see 6, 7, 8, or 9? Go ahead. 9? Okay. Come, someone flip the lights off for me, please. Number 9. We have. And then we have double, double, and then we have single, single. Okay. Find the length of IE. So we want to find this length here. And we know that 2x plus 5 and x plus 8, right? Okay. By definition, we know that we have these congruent. So this means this side here and this side here have to be equal in length by definition. Meaning this right here is actually the perpendicular bisector. This right here is the perpendicular bisector of this line. Okay? So if those are equal to each other, I can set them equal like this and do a little bit of algebra. So I'm going to subtract x and then subtract 5. Is that right? And then x is equal to 0. So that means that's 5, and that means that's 5. So what's the whole distance? 5 plus 5 is? 10. Yeah.
It's actually 8, x plus 8.
X plus 8? Oh, that's 8? Oh, that makes me feel better. Okay. That's an 8, and then that would be a 3. Thank you. And that means that has to be x plus 5, which is 8, and that's... Wait. X plus 8. Oh, shoot. X plus 8. That's 11. And then that's 11. So it has to be 22. I'm sorry. Thank you. Did I make it right? No. Good. What else we got from there? Any of those? Yeah. 8? Yep. Let's see. Like that, maybe? I think. Yikes. All right. They tell us that AC, top to bottom, is the perpendicular bisector. So this is my perpendicular bisector. So that means this and this, that distance has to be equal, even though my drawing stinks. So if this is 46, and this is x plus 2y, and this is 2x plus 3y, and 28. Okay. So if that's perpendicular bisector, this distance has to equal this distance. And then this distance here has to equal this distance. Is that all right? So we can use our algebra skills. So let's get rid of x. So I'll multiply everything by 2 here. I'll just bring it straight underneath. So I get negative 2x minus 4y equals negative 56. Add them up. Negative y equals negative 10. So y equals 10. Cool. So if y is equal to 10, let's just plug that in here. That means x plus 20 equals 28, so x has to equal 8. I do it right?
Yep.
Woo! Any others that aren't proofs yet? Yeah. All right. Proofs. Yeah.
10.
10. Starting in the beginning. Let's see. Circle. Circle, measure center of it. OM. AB. And we're trying to prove that they are perpendicular. What happened?
I don't know.
Okay, that's what we're trying to prove, right? So we have circle O given. Cool. Things that we could do about, say, circle O being given is I can go ahead and state that. Yeah, I drawn those out, so then I can say OA is congruent to OB radii, right? Is that cool? I don't know if I had to say that or not. I was just going to generate it. That's all I can really state from there so far. M is the midpoint. M is midpoint of what? AB? So that's given. Alright, so M is the midpoint. So then you could easily state that AM is congruent to MB, definition of midpoint. So that states that this and this are the same. We already knew that and that are the same. And reflexive. Yeah, we could do reflexive, but I don't know if we have to prove the triangles are congruent yet. I like the reflexive, and if you chose to do it, that'd be great. And that would show side, side, side of the two triangles. But I think what we could state,
What about
OA, OA equals OB. Got it?
Oh.
What I think we could do is this. We can, from definition, we could state that OM is perpendicular to AB. And the reason we could state that is we have two sets of congruent points away. So two sets of congruent segments. Then, that means then perpendicular. That's fine. I think that works totally fine right there. That was what the whole lesson was yesterday. I think it was, so it would be 5 point whatever theorem. I don't remember what it is. Yeah.
So if it's like two triangles like that,
Mm-hmm.
you have to prove each one is congruent to the other.
I don't think we have to in this case, because it went right to saying, hey, is this perpendicular to this? And you could say, then you could easily state that OM becomes the perpendicular bisector of AB. Okay, and the reason is, you have this and this, equal segments to the same point, equal segments to the same line segment, and then it all works out.
Theorem of Dawn.
Theorem of Dawn is where we're at. Good. Number 11? All right. Number 11. We got another cycle. I want a good circle tool on here. Come on, man. Give me a circle. Oh, dude. Yeah, buddy. All right. Who's Lucas? Lucas is out of control. He needs to start playing with matches here in a few minutes. Center. A, D. There's D there. There's A there. There's a B and C. And we're trying to prove AD is perpendicular bisector. Okay, that's what we're trying to prove, right? All right. All right, so we have circle O. That's given. And just from stating circle O is given.
OD is congruent to O. No.
Nope. But what I can do is I can draw my lines here and then easily state that OB is congruent OB to OC radii.
Didn't you say that about OA?
I could say that. I don't know if I need to. If you threw that in there, that'd be fine. So if I could state that, you know those red lines are congruent. What else can I state? Oh, then I could go OD is congruent to OD, and the reason I'm going this way, that's reflexive. So then that tells me this, which is great. That tells me then that triangle BOC is isosceles, and that's just our diagram, right? We have this yields to this, which then would tell you that angle OBD or OBC is congruent to triangle or angle OBC and OCD.
You don't know what that is.
What? Don't know what is.
Nothing.
Okay. All right. So then I have angle side side. That's not going to help me much. Was there other givens that I'm forgetting? Oh shoot. Okay. So AB and AC are congruent. AB is congruent to AC. Great. So that's going to tell me that and that are congruent. So, oh shoot, that's given. And the reason I could have said that was definition of isosceles. I probably didn't have to prove that. So with that, then I can go OA is congruent to OA. We have a reflexive again. And that's going to then tell me that triangle AOB is congruent to triangle AOB and AOC. Because now I have side, side, side. And I don't even know if I had to do that. But I can then go ahead and say that AD is a perpendicular bisector of BC. And the reason is I know I have this congruent to this, so I have that segment, and now this segment, I didn't even have to prove the triangles were congruent. Two sets of congruent segments. Then bisector, something like that. Cool. I think that would help you on the rest of those proofs. Good? All right, make sure those are stapled and bring them on up yonder. So let's see how we do. These sheets of paper and your compasses so we can generate triangles. Okay, so I am going to draw just a standard triangle, nothing special about it. Still with me? Yeah, draw something similar to what I have, if you don't mind. Doesn't have to be exact, don't worry. If it's not exact, you're not wrong.
How big?
You picked it. Just don't use the edge, it's real too skinny. Yeah.
Do you have a pair of scissors? Because it like won't open.
Ow, that's big. Oh my god.
No one loves you.
No, we already tried.
All right. You make it, the size that you feel is appropriate. I wouldn't make it the whole size of the sheet because you're going to run out of room. So make it somewhere where I would say it's about anywhere from 1/15 of your sheet of paper to probably about 1/8.
What about 1/17 of 30?
1/17 should be good.
Okay.
Yep, you're right.
Let's do
All right. No, you got it. I'm sure you're fine. All right. So our first one is let's construct. What was our first construction? Perpendicular bisectors? I don't think that was our first one. That's
No,
true.
the centroid.
Centroid. All right, so the centroid. So this is the medians, the middle of the sides, right?
Yeah.
All right, ready? So, any thoughts on how I might find the center of any particular side with my compass?
Okay, so you measure it up, put the point on a vertex of the triangle.
Okay, so open up your compass,
Yeah, stretch it a bit, more than halfway,
more than halfway.
and then you draw your arc.
All right, draw my arcs. So let's change the color. So I can draw kind of a big arc. Bring your compass over, maybe flip over your pen, and then swing the same size arc both ways. Okay? It can go outside of it, it can go partly inside, it doesn't matter.
And then you draw the 2 points.
So,
You draw a line, you connect the 2 points,
there you go.
so that after you do that, where the line intersects with the triangle, that's where you draw that point, and connect it to the opposite angle.
Okay, so you connect these 2 points together. I would probably make this point kind of light, but realize this. This point right here cuts this segment and this segment into 2 equal parts. What should I officially do to start getting the centroid though? Do what? I'll do all 3 sides eventually, but what should I do next? What should get me start getting my centroid? I'm going to use this point and one other point. And the vertex, good, so the opposite vertex. Okay? So, maybe we'll do that in... All right. So this right here, this yellow point right here, this yellow or green, that's what we're going to do. Now we're going to duplicate this. We're going to duplicate this more. So here's the nasty thing about the constructions. I would say you need to get rid of some of your stuff. Whatever you can get rid of. Whoops, undo. Whatever you can get rid of that you don't need. Okay? Do I need this line right here anymore? Do I need the black line any longer?
No.
No, I'm going to get rid of it. Do I need my arcs any longer?
No.
No, so I'm going to get rid of them. Do I need either of them? Nope. Get rid of it. Okay? So notice what I did. I erased them. So don't make your arcs so dark. You can make them light. All right, so this side's taken care of. How do I find the other sides now?
Same thing.
Same thing. So I'm going to put my pointy end. I'm going to have it open a little bit more than halfway.
Oh, so just the length, you don't have to keep it the same.
Nope. It does not have to be the same. So I'm going to draw that. Bring my pointy end to here. And I'm going to draw that. Okay? It's a coincidence that this is looking like it's there. So what I could do is I'm going to draw me my line of best fit. I'm going to draw from there to there. Okay? Where does my point of the median take place? Between what colors? Black and? Black and? So here's my median here. Okay? I'm going to draw that in again. I'm going to take this. We're going to use a green color again. Now I'm going to connect from here through there. And there's some things I don't need. I don't need this. I don't need this. I don't need this. Okay? Now, bless you. Let me ask you all this. Where is the, if you drew those two correctly, where is the center of mass taking place right now? In the middle of this green. Okay, so do I need to go and swing the arcs on this one to find the centroid? No. Watch what I could do right now. I could say, all right, well, let's use our green color again. I'm going to go from this corner right through here. That's where the center of mass is. And guess what this point is right here? Centroid. So this is our centroid right there. Things to know about this shape. Things to know. 1 tick, 1 tick. Those are congruent. 2 tick, 2 tick. Those are congruent. 3 to 3. Those are congruent. Look at our centroid. That's all you have to do to find the centroid. Okay, I would say draw, make 2 of your constructions, and then draw from the vertex you didn't use that through that. Now, if you draw it and it's like, oh my gosh, it's totally off. Like if I were to draw this line in right here and this line coming down right here, because this dot's way down here, you did something wrong. Okay? So the centroid will be the medians of each of the sides of the triangle every time. Yeah.
So the green lines are the medians?
Yeah, green lines are the medians. Okay? Other things to know about this would be, let's do, what do I know about the distance from here, right here? I don't like that color. I don't want that. What can you tell me if I have A, B, C, and I'll call this X, what can you tell me about the distance from A to X to, oh, and I have to label this, L, M, N. From L to N. What is the relationship between segment AX to LN, or XL?
2/3.
So this is how far to this?
2/3.
So if the whole line is, if AL is our whole line segment, that means that the distance from A to X is 2/3 AL is equal to AX. And then XL is equal to 1/3 of the entire segment.
That doesn't make sense.
Okay, so this is 2/3 of this distance. This is 1/3 of that distance if I go from there to there. Okay, so other things I could state. If I were to say that, if I said 1/3 CN, 1/3 segment CN is which segment? 1/3 CN. What's 1/3 of it? XN. What is 2/3 of CN? X what?
C.
XC. Okay? And then what was the other one? BM? So what is 1/3 of BM?
XM.
XM? And then 2/3 of BM?
Yeah. XB.
XB.
XP.
Bless you. So those are the relationships between the sides. Yeah.
Wait, so all of the medians that go from the vertices,
Okay?
are all equal?
No. They are not equal. So this distance is not equal to this distance, is not equal to this.
Oh.
It's just if I had this, let's say if I know this whole distance to be 12, this is 2/3 of 12, which is 8. This is 1/3 of 12, which is 4. That does not mean that this one has to follow suit. The relationships of the segment as a whole, from B to M, C to N, or A to L, it's the 1/3, 2/3 relationship to the centroid. Does the centroid have to fit in the middle of a triangle?
Yes. Oh, wait,
No. It doesn't have to be in the middle. Okay? It's just cutting the sides in half. Let's see. Can I move off this one? And I think I could start the next one. All right. What happened? No? All right. Let's bring up a shape. Let's bring up this triangle. All right. All right. Altitude of a triangle. Altitude's how tall it is, correct?
Yeah.
Indeed.
Altitude's how tall it is. Everyone agreed?
Wait, we get a different sheet of paper now?
No, you can do it on the back, or you can squeeze it on whatever side.
Yes, so you're saying-
So, something that is important to know about altitudes. This will help you every time that you're doing construction of altitudes. Okay?
What's your
Extend
razor scooter?
extend each of the sides.
Okay.
Look, I see. Oh, stop making that noise, please. Oh, it's making me feel so bad.
Yeah, so are you okay, man?
Stop.
You seem kind of like disoriented.
I'm fine.
Are you sure about that?
That's the first step as far as finding the altitude. Okay? So I extend all the sides of my triangle. Okay, because the altitude a lot of times it's going to be the height. It's how tall it is. It could happen outside of it. Does it have to happen outside of it? Not all the time. Okay? Ready? All right. I gotta remember this. Hang on, it's coming. Okay, I'm gonna break out the compass. I'll do this for one side, and then we're gonna run out of time. Oops, get out of there. Come measure. I think this is right. Come measure over halfway. Is it right?
Oh, do we do that?
Hang on. Don't do it yet.
Okay, but I see where this is going.
Oh, I see. Okay. Okay. If I want to find how tall a triangle is this way, I'm going to open the compass enough to where if I swing this arc, it crosses twice.
What the?
Okay? Is that right? Oh,
Matter where.
Do we need to keep these?
yeah. Hang on to those. Bring those tomorrow. We're gonna run out of time. We're running out of time. I gotta make the altitude better. We'll continue on the last two constructions tomorrow. I'll see you 5-4. Just kind of start preparing yourself for the test that's coming.